So now I'm going to put a singlet lens here with an effective focal length of 100 millimeters, bring the Gaussian beam to focus, and then look at the phase aberrations of that Gaussian beam. So to design a lens, I could design one from scratch, or I could just buy one out of a catalog, and that's what I'm going to choose to do in this case. So I'm going to go to Libraries, Lens Catalog, and I've set myself up a search to look through the Edmund Optics catalog for, I'm looking for 100 millimeters effective focal length, so I've given myself a little bit of range on there, and I'm looking for something bigger in aperture than about 10 millimeters, so I set that as my minimum and then put 15 as my maximum. And I want singlet lenses. I don't want any gradient index, A-spheres, toroids or meniscus, and so that gives me this number of lenses here. You can see I've got a fairly wide choice of lenses, and I'm going to go for this fellow here, 12 millimeters entrance pupil diameter, planospherical lens, and I'm going to press insert. If I press load, this will create a whole new lens design with just this lens in it, but I want to insert this lens into this lens design, so I'm going to say insert, and I'm going to insert it at the surface where the lens goes here, and I don't need the object surface of the lens that I'm inserting, so I just press OK and then close, and that gives me my lens. So now I just need to tidy up the editor a little bit. You'll see that I've brought my lens in, everything is correct, but I'm just going to put the 100 millimeters back focal distance onto that surface and remove this surface. And now I just need to think about what is the best back focal distance for the Gaussian beam that I have in mind. And to answer that, I'm going to set this back focal thickness to be a variable. The V here means that ZMAX can change it. And I'm going to go to the optimizer and go to the merit function editor, and I'm going to say that what I want is a particular Gaussian beam size. The operand I want is Gaussian beam paraxial size, and I want to get this Gaussian beam measured at surface number 4. I know from the manufacturer's datasheet that the beam waist is 1.15 millimeters, and that occurs at a distance of 2.8 meters or 2,800 millimeters away from the output port of the laser, because it's a Fabry-Perot style laser. I want to target this to be as small as possible, and I'll give that a weight of 1. If I update the merit function, you'll see that the Gaussian beam size is 19 microns. And if I optimize, start, very, very fast, you'll see now I've got a 16 micron spot size at a distance of 99.224 instead of 100 millimeters. Now that's fine, that is the best paraxial beam size, but what do the aberrations of this lens do to that Gaussian beam? Well, to see that, we need to go to Analyze and Physical Optics, and then I'm going to set this up as follows. I'll leave auto apply on for right now. I'm going to set it to go to beam number 4 or surface number 4, and I know that relative to surface number 1 the beam waist is 2.8 meters away. I have a Gaussian beam, and I know that the Gaussian beam is 1.15 in X, 1.15 in Y, and I'm going to use a reasonable sampling. And if I just check this automatic button, it will set the size of this beam to be what I want, and I'll just say OK, thank you very much. So here's my Gaussian beam. It looks good, but how do I know how good it really is? Well, it's more useful to look at phase than irradiance when you're looking at the aberrations of a Gaussian beam. So if I just choose this to be phase, you'll see now I can see a phase cross section across the, or a phase plot of it, and I'd like to now just look at a cross-sectional plot. And that's really useful. This is showing me that I'm getting something like, well, this is 0.015 of a radian. So this is something like lambda by 75 or so here. So this is telling me what the aberration of that beam looks like, and you can see that it has the Gaussian shift up here, a basic focus type of shape, and then spherical aberrations bring the phase back up to zero here. So that's how good my lens is. Just remember that this is about 0.01 of a radian right here.